Hi guys, you're welcome back to this new episode with Math with Delmy. It's been a while, but I'm back again. Here we have an interesting question which we're supposed to let the function be a rectangle, okay, and be differentiable such that f of 2 equals 2 and the absolute of f of x minus f of y be less than or equal to 5 to the power of x to the power of 3 on 2 for the difference of x, y absolute. So for all members of x and y belonging to real numbers. So let g of x be equals to this function here, to this expression of this function here. So x cubed f of x. Then we should find g prime of 2. First of all, this is what we are supposed to find. G prime of 2. So means we need to find a differential of the g function. So first we differentiate this. So that would be g prime of x equals, since this is a product, okay, this is a product, so that means we need to apply the product rule. So we'll be having, you differentiate these and make this constant, so you have 3x squared f of x plus x cubed f prime of x. All right, so the next thing we do is we insert the value 2 into it. So we're having g prime of 2 equals 3 2 exponent 2 3 exponent 3, then 2 exponent 2 f of 2 plus 2 exponent 3, then f prime of 2. So we know that this f of 2 here will be equals to 2, that is given here. So this will give us 4, 3, 12, 24. So we have g prime of 2 equals 24 plus the term here. So this will be 8 f prime of 2. Now the problem will be to find what f prime of 2 is. So we know that f prime of 2 will be the differentiation of the function f of x. Good. So since we know that the interval, okay, the interval here is it's a Lipschitz condition, okay, so that means that we can derive our f of x from it, okay. Let's go. So that means we can know that f prime of x, okay, should be equals to the change of f of x, okay, with respect to the change in x. Okay, so we already have the change in the f of x, which is given as in here. All right, so that means that we will be having the absolute of f of x minus f of y on, so the change in the x, so these are the x's, okay, so the x is the independent variable, so the independent variable are worth it in the bracket. So that means that we'll be having x minus y. Okay, so since this should be absolute, this should also be absolute. Okay, so if we should compare this with this, so we realize that you can make this f of x here, f of x minus f of y, that is the numerator, the subject. Okay, so making it the subject, you have this can be multiplied through. Okay, you can use that to multiply this. Okay, so that means that for the f prime, so that means that for the f prime, we'll be having f prime of x, okay, will be equals to the absolute. This condition is already known. We know it to be less than, it's already here, so we say it should be less than or equals to this. So since it's an interval, it should be less than or equal to this. So we put that into this expression here. So we'll be having 5 bracket open, the absolute of this, let's close 3 on 2, all on the absolute x, y. So we can solve this too, okay, by indices approach. So the power here 1, you solve this, so you merge them, you have f prime of x will be equals to 5 bracket open to the absolute difference, okay, exponent 1, exponent 1/2. So we have this. Now it's how to get, now we need to now insert the value here too into this. So we have f prime of 2 should be equals to 5 bracket open the absolute of 2 minus, so what will be the value of y then when x is 2? That is simple, it's already given in the question you have here. So f of the independent variable, which is x, so here, which is x, gives us the function, the whole values of the function, which is y. So when x equals 2, y equals 2. So you have 2 minus 2. Okay, so I have this, so this, all this gives 0, because 2 minus 2 and 0. With that, we can go back to the equation here, insert 0. So we'll be having 8 times 0, 0. So the answer will be 24. So that means g prime of 2 should be equals to 24. And that is our answer. Thank you.